Hello friends, thank you very much for watching my first video. In this video, I'm going to solve some maths questions from JEE Mains 2015. Let's start. Let alpha and beta be the roots of the equation x squared minus 6x minus 2 equals 0 if an equals to alpha to the power n minus beta to the power n for all n greater than equal to 1, then the value of a10 minus 2 times a8 over 2a9 is equal. So we have one quadratic equation x squared minus 6x minus 2 equal to 0. We know that alpha and beta are the roots of the equation. Now one common mistake that people try to do is solve for this equation. Here you can see that the discriminant, which is b squared minus 4ac, is not a perfect square root. That would be 36 minus 2 times 4 times 1, which is 8, which is 28. So if you try to solve for x, you will get minus b, which is minus 6, so that's plus 6, plus minus under root 28 over 2a, which is 2. So you won't be able to find alpha and beta, and if you try to plug them into the equation, you have to find them to the power 8, 9, and 10, which is almost impossible. So we'll try to solve it with a better technique. So let's try to evaluate this term. A10 minus 2 times a8 over 2 times a9. So we know that a10 is alpha to the power 10 minus beta to the power 10 minus 2 times alpha to the power 8 minus beta to the power 8 over 2 times alpha to the power 9 minus beta to the power 9. So if we were to factor out alpha to the 8 and beta to the 8, we get alpha to the 8 alpha squared minus 2 minus beta to the 8 beta squared minus 2 over 2 times alpha to the 9 minus beta to the 9. Now we know that alpha and beta are the roots of the equation, which means that they satisfy this equation. So if you plug in alpha in place of x, the equation should hold. So alpha squared minus 6 alpha minus 2 equals to 0, which gives us that alpha squared minus 2 is equals to 6 alpha. Same way, beta squared minus 6 beta minus 2 equals to 0, which gives us information that beta squared minus 2 equals to 6 beta. So let's substitute these values in here. So we get alpha 8 times 6 alpha minus beta to the 8 times 6 beta over 2 times alpha to the power 9 minus beta to the power 9. So here it becomes, the numerator becomes 6 times alpha to the 9 minus beta to the 9 over 2 times alpha to the 9 minus beta to the 9, which comes up to be 3. So the answer for this question is option 3, which is 3. Let's move on to the next question. Let fx be a polynomial of degree 4 having extreme values at x equals to 1 and x equals to 2. If limit x tends to 0, 1 plus fx over x squared equals to 3, then f of 2 is. So we know that there is a function fx having extreme values at x equals to 1 and 2, which means that the derivative of x equals to 0 at x equals to 1 and 2. So we can write that f prime of 1 equals to 0, which is also equals to the f prime of 2. And we know that limit x tends to 0, 1 plus f of x over x squared equals to 3, which also tells us that the limit x tends to 0, f of x over x squared equals to 2. We can just subtract 1 from each side since 1 is a constant. The question could have been given with this limit, but they just added 1 to confuse people. Since x is approaching 0 and the limit is 2, and we also know that it's a 4-degree polynomial, so let's assume that fx is a times x to the power 4 plus b times x to the power 3 plus c times x to the power 2 plus dx plus e. Now, if we were to plug this fx and find the limit, so here we get one information. If this limit is equal to 2, then we get that the value of c, which is the coefficient of x squared, that is 2. The value of d, which is the coefficient of x, is 0, and the constant term e is also 0. If d and e were not 0, then our limit would have a different value. So now we have that the function is a times x to the 4 plus bx cubed plus 2x squared. And we need to find the values of a and b. So let's take the derivative, which gives us 4 times ax cubed plus 3 times bx squared plus 4x. And we know one thing, that f prime of 1 and f prime of 2 equals to 0. So we will get two equations from there and we can solve for f of x. So if we plug in x equals to 1, this becomes 4a plus 3b plus 4. This is equal to 0. And f prime of 2, that would give us 32a plus 12b plus 8 equals 0. So this becomes our first equation, this becomes our second equation. And if we multiply the first equation by 4, so that will become 16a plus 12b plus 16 equal to 0. And we can subtract these. So the terms we're having b gets cancelled. So we have 16a minus 8 equals to 0, which tells us that a is half. If we plug in the value of a in any of these equations, we get 4 times half plus 3b plus 4 equals to 0. So we get 6 plus 3b equals 0, which tells us that b is negative 2. So if we plug the values of a and b into our fx, we get 1 by 2 x to the power 4 minus 2x cubed plus 2x squared. This is f of x. Plugging in the value of 2, f of 2 would be 8 minus 16 plus 8, which is equal to 0. So f of 2 is 0, which is option 3. Let's move on to the next question. The integral of dx over x squared times x to the power 4 plus 1 to the 3 by 4 equals. So we have a integral. So we cannot solve this integral directly. So we'll perform one substitution here. But before performing a substitution, we can rewrite this integral as, so what we did here was factor out an x to the power 4 and bring it outside. Now we can substitute this term as t to the power 4. You can also substitute as t, but substituting as t to the power 4 makes things a little bit easier. Calculation is easier. So it becomes minus 4 over x to the 5 dx equals to 4 t cubed dt. It says that dx over x cubed equals to minus t cubed dt. So here you can see that this term dx over x cubed becomes something nice. That's why we had substitute as t to the power 4. So now substituting these values back into our integral, we have, so dx over x cubed 1 over x to the 4 plus 1 to the power 3 over 4. So we know that dx over x cubed is minus t cubed dt, and in the denominator we have t to the 4 to the 3 over 4, which gives minus t cubed over dt, t to the power 3, which is basically integration of minus 1 dt, which is minus t plus c, substituting the value of t back. So from here we know that t equals 1 over x to the 4 plus 1 to the power 1 by 4. So this gives us 1 plus 1 over x to the power 4 to the power 1 by 4 plus c. This is the value of our integral, which is option 4. So you can just take this, multiply x to the 4, and that gives you the answer. Let's move on to the next question. The distance of the point 1, 0, 2 from the point of intersection of the line x minus 2 over 3 equals to y plus 1 over 4 equals to z minus 2 over 12, and the plane x minus y plus z equals to 16 is. So first things first, we need to find the point of intersection between the line and the plane. And we do this by, so we equate the line to be equal to a term called lambda. So from this equation, we get that x equals to 3 lambda plus 2. We get y equals to 4 lambda minus 1. We get z equals to 12 lambda plus 2. And now we can plug these values of x, y, and z into our plane. So x minus y plus z equals to 16. 3 lambda plus 2 plus 4 lambda minus 1 plus 12 lambda plus 2 equals to 16, which gives us 11 lambda equals 11. So we have lambda equals to 1. So we know the point of intersection of the line and the plane. So plugging in as lambda equals to 1, x is 5, y is 3, and z is 14. So we have 1.5, 3, 14, and our point is 1, 0, 2. We need to find the distance between the two, which is fairly simple. So this is 4 square, which is 16, plus 3 square, which is 9, plus 12 square, which is 144, the sum of which is 169, and the square root of 169 is 13. So the answer is option 4, 13. Let tan inverse y equals to tan inverse x plus tan inverse 2x over 1 minus x squared, where mod x is less than 1 over root 3, then the value of y is. So here, let's make a small substitution. Let's make a substitution that tan inverse x equals to theta. So we know that x equals to tan theta. So then we have tan inverse y equals to tan inverse x plus tan inverse. Since x is tan theta, we have 2 times tan theta over 1 minus tan square theta. And if we remember our trigonometric identities correctly, then we have tan of 2 theta equals to 2 tan theta over 1 minus tan squared theta. So then our tan inverse y becomes theta, since tan inverse x is theta, plus tan inverse of tan 2 theta. And tan inverse of tan 2 theta is 2 theta, so that is basically 3 theta. So now we know that y equals to tangent of 3 theta, which is 3 tangent theta minus tangent cube theta over 1 minus 3 tangent squared theta. We all again need to remember the trigonometric identity here. And now tan theta is x, so that becomes 3x minus x cubed over 1 minus 3x squared, which is option 1. Let's move on to the next question. The number of common tangents to the circles x squared plus y squared minus 4x minus 6y minus 12 equals to 0, and x squared plus y squared plus 6x plus 12y plus 26 equals to 0 is, pardon me for even picking up the Hindi section. So here we have two circles. Let's try to find the center and the radius of both of them. So this one we can add 4, add 9, so we need to subtract 13. So minus 30 minus 12 is 25. So from here we know that the equation of this circle is x minus 2 squared plus y minus 3 squared equals to 25. So the center of the first circle is 2, 3, and the radius is 5. Let's do the same for the second circle. So this is x squared plus 6x plus 9 plus y squared plus 18y plus 81. So we added 90. So we need to subtract 90. So that would give us 64. So we have x plus 3 squared plus y plus 9 squared equals to 64. So we know that the center of the second circle is minus 3 comma minus 9, and the radius of our second circle is 8. So if we were to show them in this Cartesian graph, the center of the first circle is here with a radius of 5, and the center of the second circle is here with a radius of 13. Pardon me for the bad drawing. One thing to note here is we need to find the distance between the center of the circle, and that is fairly straightforward. So it's 5 squared plus 12 squared, which is 169, and under root of 169 is 13. And you can see that R1 plus R2 is also equals to 13. So we know that these two touch externally. This is the distance 5, and this is distance 8. So we know that these two touch externally. So if they touch externally, we know that they'll have three common tangents. One of them would look something like this, the other one would look something like this, and the third would look something like this. So it would have three common tangents. So the answer for this one is 3. That's it for me today. Thank you very much for watching the video, and please subscribe so that you never miss a notification. And if you have any suggestions, please let me know in the comments section.